What's going on, you guys? Mr. Allen here with some more wonderful coordinate geometry here. We're going to find the area of this quadrilateral ABCD, and usually it does help to figure out what type of quadrilateral it is so we know which area formula to apply. And I'm going to tell you what, this is looking a little trapezoidy to me. Let's see if it is. One easy way to tell is look at my upper and lower bases. If they're parallel and nothing else wonderful is going on, like more parallel sides, then we know that it's a trapezoid. So up here, my y coordinates 5 and 5. That's a horizontal line, -3, -3. That's a horizontal line. This is a trapezoid, okay? And it also looks like this is a vertical line right here, as my x-coordinate is not changing. Therefore, that's a right angle. Ooh, okay. So instead of, in this one, even though I said we want to figure out what area formula to apply, instead in this one, here's what I'm going to do. I'm going to break this thing apart, okay? I'm going to use a fancy straight edge here so it looks real nice. All right, I'm going to pop down here on B all the way down and create a lovely height right here with a dashed line. And essentially what we're going to do is we're going to break this thing apart into a rectangle or square and a triangle. I say rectangle or square because I'm not sure what it's going to be, okay? But this is super helpful if you ever forget your trapezoid formula, which is area of a trapezoid. Area of a trapezoid is equal to 1/2 base 1 plus base 2 times height. So if you want to use that, you could. I'm going to go about this in a different way in this problem, just in case you didn't remember that one. There's other ways of writing that one where you just put it all over 2, whatever. Okay, I'm going to break this apart into two different things. So I've got this quadrilateral right here, and I have a triangle right here. So let's work with this quadrilateral. What are my side lengths? Well, I'm going from -5 to +2. That's a length of 7. This guy right here, I'm going from, let's see here, +5 to -3. That's 8 right there for that side length. So we're dealing with a rectangle here, right? We said this was a right angle. I know I'm dealing with a rectangle. Had this come out a little bit more, I would just be doing 2 different triangles and something in between, right? But this one's just 2 pieces. So the area of this inside, or this rectangle that we have here, is going to be 56. 8 times 7, right? So area of the rectangle, in case we didn't know that, is 8 times 7. So that's going to give me 56. Now I can work with my triangle. I'll swap to a different color here. All right, so for a triangle, area of a triangle is 1/2 base times height. All right, so what's my base length here? Well, this would be the coordinates. Let's put some new coordinates here for, let's call it E, right? Yeah, E hasn't been used. That's going to be +2, -3 for E. So this length here, it's horizontal, so I can count it, right? If it's a diagonal, I can't count it. I got to Pythag it. I got to use distance formula or something. So here I'm dealing with from 2 to 5. That's a length of 3. And then this length right here is actually going to be the same as that 8, right? So that guy's 8. So now I can plug this in. I got 1/2. Then I've got my base, which is 3. My height, which is 8. So that's 1/2 of 8 is 4 times 3 is going to be 12. Or you can do 3 times 8. That's 24 times 1/2 is 12. Either way, I've got my 2 areas. So if I add these 2 together, let's see here, area of the trapezoid now is equal to 56 plus 12. And then we got what? That's 68. There we go. Units squared. That's my final answer. However, I have seen some like SAT type problems where they ask you like which of the following is equivalent, and they leave it in the like the addition type of form right there. Maybe one of them ends up with a radical in it, or just like 2 decimals, and it's terrible. They make you think about it in this way, where it's a rectangle or a square and a triangle, and they leave it like this rather than adding the 2 together. So be on the lookout for that. But just another way of looking at a trapezoid there, breaking it apart into rectangles or squares, and a couple triangles or just one triangle. That's it. That's dope. See you dogs later.